If you're new to PCG, it might seem a little complicated and overwhelming at times when you first get into it, but it is extremely powerful. Throughout the series, we're going to go from just the introduction of how PCG works to a full building with interior and exterior, as well as probably so much more with the introduction of the new 5.4 features. In 5.3, we created this actual building here using fully PCG. That also includes some interiors, and we're going to take this and make it considerably better and make it far more modular thanks to the new 5.4 features. And today's part one, we're going to take this building here and we're going to create it. We're going to have the option to have different amount of floors. And as you can see, each floor will get its own floor on each level. We'll also go ahead and set it up that we can have a unique floor every X floor. So you can see there's a different one every second floor. So if I do 6, it's every second. We can also change the amount of them and change how often they appear, as well as in which section they appear, starting at what floor. I'm going to be showing you loops, subgraphs, and everything to get you started. So let's get into it. So here I am in a brand new project. Only thing I've done is I downloaded some Megascan's assets and materials, and that's pretty much it. So to get started with PCG, the first thing you need to do is actually enable it by going to Edit, Plugins, and then searching for Procedural and turning on Procedural Content Generation Framework, PCG, right here. It'll tell you that it is in beta. Just hit yes, and then go ahead and restart your engine. Once you have restarted, we can go ahead and get started. We're going to need a few things to begin, starting with the actual PCG graph. So let's go ahead and right click and go to PCG and PCG graph. And I'm just going to call it PCG Building, as this is going to be our main PCG graph. And we're also going to need a blueprint to house the spline that is going to populate our building. So I'm going to right click, search blueprint class, and grab ourselves an actor. And this is going to be our BP building. With that created, let's go ahead and open up our blueprint actor. And now all we need to do is create basically a spline that's going to house our PCG graph and add our PCG graph to it. So in the components, I'll go ahead and hit add and search for spline. And we want to add a regular spline. Now this is just a single line, and ideally we already have it kind of pre-configured. So what I'm going to do is select this right point by clicking on it and press delete to remove it. And then I'm going to right click on the original point and then go to spline generation panel. And then I'm going to generate a square. Now the square by default, let's make it something like 1000 units in size. That seems good. And now I can close out of here. Now, we're not quite done here. If I go to the detail panels and search for closed, we need to make sure this is a closed loop. So go ahead and check this on, and you will see that we get this kind of loop. So with the original point still selected, I can go ahead and just move it to the side and then press delete. And you can see it has created kind of a box, but it has kind of curved this area. So I'm going to select this original point, right click, spline point type linear. And now we have 4 points that are all completely connected in a nice, convenient square. So now let's go ahead and add another component. This time is going to be our PCG graph. So it's going to be just PCG. And here in the graph, we want to plug in the graph that we created. So with it selected, go ahead and just input it into the graph, or you can select it from the drop down, whatever is more convenient for you. And that is pretty much all we need to do with this blueprint for now. Now we are going to be going back to this blueprint as we're going to need to add some variables to make it easier for ourselves. So you might want to keep it open for convenience. But once you're ready, go ahead and open your PCG graph and we'll get started here. The first thing we're going to want to do is grab all the points that are going to be making up the floor and the walls of this building. And then we're going to want to kind of reuse them in other locations. So we can start using new tools from 5.4 almost immediately. So let me show you. So to get started, we're going to right click and search for get spline data. And this is going to get our spline from itself, from the blueprint that it's already part of, which is exactly what we want. And then we want to grab our spline sampler. Now let's go into sample our spline. Our dimensions, instead of on spline, we want on interior. And we also want to check on unbounded. That way it properly detects all the points. If I have it selected and I press the hotkey D, you can see this icon appears. And this allows us to debug the actual graph. Now, there's nothing in the scene right now to debug. So what I'm going to do is grab our BP building. I'm going to drag it out into the scene. And you can see immediately we see this large white square. Now, this is because we are sampling 100 and 100 here. Now, you might see this error right here. One or more rows of the spline interior fail to sample. Ensure the spline points are not overlapping. Now, in our case, we don't have any overlapping spline points. In fact, if I select each one of these spline points and move them, you can see it is actually all individual. This seems to be just a bug, just states that there's overlapping points, but As you see here, none of the points are overlapping. So this is a false error. Everything still works correctly as it should, but for some reason, this error still persists. Occasionally, it will realize that everything is fine and it will stop throwing the error, but sometimes it still is here. So don't freak out. It's fine. Now, the first thing we want to do is actually use our wall size to split up all of these points, because right now they're way too packed. And if I was to spawn a wall, for example, it would just be like very close together and it would not work. So we need to figure out what our wall size is. So let's go to our BP building, and I'm going to add a new variable here called wall size. I'm going to make it a float, and I'm going to make it exposed by hitting this eye icon on the right. And then once I compile it, I can go ahead and set a default wall size. Now, in my case, the wall size will be 310 units. I'm hard-coding this right now, but in future parts, we will get the wall size dynamically based on any input that we're going to have, and we're going to be able to swap them out very easily. But for the time being, as this is just the beginning, we're going to hard-code it as 310. Now, this does depend on your specific wall size, so just keep that in mind. So with that in, I'm going to go ahead and compile and go to our PCG Graph. And now if I open it, we're going to have access to all of the inputs, which are pretty much the same ones we have here on the right side. So what I need is to get access to that variable from our blueprint. So in our PCG building, I'm going to right click and search for get actor property. And now on the right in the detail panel, under property name, we want to put in that variable name. So we'll type in wall size, just as we have it in the variable name without a space. And then we can plug it in. Now in our case, we want to change the interior sample spacing. So we're going to look for that on the right here. And here it is, interior sample spacing. We're just going to plug this in directly, and I can go ahead and close this up. And now if I press D and sample it, you can see we have our points a bit further apart. So that is perfect. Now, one thing you might notice is there's no points right over here, even though it seems like it should be. Now, unfortunately, the spline is not perfect, and sometimes you need to kind of fiddle it with a little bit to get the points to appear where you need them to be. As you can see, it is just a little bit fiddly. Unfortunately, that's been around since the beginning, but once you get it just a little bit larger than you kind of need to, it usually falls right into place. Now, I've gone ahead and quickly restarted my Unreal, and as you can see, that error that we had before is gone. So this is why I was saying that it's fine that it throws an error. It is just a bug. So as long as you check and there's no actual points overlapping, you can go ahead and ignore it. As you can see, everything's fine. It is all debugging and everything is good. But now we have all our interior points, which is kind of the points we're going to be using for the floor down the line. Now, we're going to need access to these points all the time. Instead of dragging out from here and putting it everywhere, we can start making use of a new 5.4 feature, and that is the new named reroutes. So if I search for named, I can add named reroute declaration node, and then we get this output where we can actually go ahead and reuse it somewhere else. So with it selected, I can press F2, and then I can go ahead and rename it. I'm going to call this original spline points, as these are the very start where we actually start using this everywhere else. Well, fantastic. We now have our base points ready. Now we also need to get the exterior wall points so we can start putting in the walls. Now, because we're going to be using the setup to get the walls now and in other times in the future, possibly, it'd be good to be able to just reuse this. So what we're going to do is create a subgraph that we can reuse down the line. Now, there's two ways of doing it. You can create the subgraph right away, or you can create all your graph as you would normally and then compact it into a subgraph, which is what we're going to do to make it easier. But for that, what we need to do is get our original spline points. Now, instead of dragging out, I can just right click and search for original spline points and just grab that. And that just works as a regular reroute node like you would in materials. We're going to need to grab our wall size. We're going to need that as well because we need to know the spacing. And one other thing we're actually going to need is the wall thickness. Now, we haven't added that yet. Depending on your wall and depending on where the pivot point is, you might need to offset it side to side, kind of in depth. So in our BP building, we add another variable, and this is going to be our wall thickness. Type is going to be float as well, also exposed. And I'm going to compile it and give it a default value of 40. Because for the mesh that I'm going to be using, this is a good value. And now I can just go ahead, take our actor property and duplicate it. And instead of wall size, I can type in wall thickness. Now, if you're worried about this being misspelled, if I just go ahead and put an extra letter in here and press enter, you'll see immediately it says error. There's nothing of that name in the original blueprint actor. So you'll know immediately if you misspelled it. So I'll go ahead and remove the extra letter and the error goes away. Now, if you're worried, you can always copy paste. probably is the easiest way. It's up to you. So the way this is going to work is we're going to take the actual points that we just generated, and we're going to copy them up, down, left, and right. And depending on where we copy them, we also rotate them accordingly so they'll all face the correct way. And then we will remove the points that are originally there because they are overlapping each other. And then once we have removed the overlapping points, then we're left with just the exterior walls that have been pushed out from the original. So from this original spline points, we're going to need a transform points node. So I'll search for transform points, and I'm going to need 4 of these. So I'm going to take it, I'm going to duplicate it 3 more times. And now I'm just going to double click on this spline, and I'm going to add a reroute node, and then I'm just going to plug it into the input of all 4 of these. This will just make it easier so I don't have to drag it out from the original. Now each one needs to be offset a different amount based on the size of the wall. So I'm going to open up the first one. I'm going to move the other ones kind of out of the way. What you need to do is offset it in a certain direction. Now, depending on which one it is, we need to offset it basically by half of the X or half of the Y value, and in either positive or negative. And we can do all of this math right inside of PCG graphs. So to do that, I'm going to grab our wall size, and I'm going to just drag out of here and search for divide. And now I want to divide it by 2. Now, you can't just type in 2 here into output source 2. That unfortunately does not work. It doesn't throw you an error, but this will not actually work. So what you need to do is drag out of NB, search for create attribute. And now you have basically a blank value you can just type in. Now the type can remain as double, and we're just going to have the double value be 2. With the output target being none, that is fine. Now the device throwing error because we have 2 here. I'll go ahead and reset the property to its default for last. And now we have our wall size divided by 2. We currently have basically a single float value, and it wants a vector. So we need to convert our float into a vector. Well, there's a node that we have. If you drag out of out, search for make vector attribute, you can create a vector. Now, by default in the output type, it is vector 2, but instead we want vector, which is a X, Y, and Z. And in this case, we want it to be in X. Now, if you open it up, there's a lot of actual other inputs, but don't worry. Just think of it as X, Y, Z in terms of your inputs, and that's all you really need. I'm going to take our transfer points and just move them to the right a little more to make room. And now, in the first one, in this very top one, I'm going to drag from this out make attribute into offset min and offset max. But instead of dragging it all the way from the start, I'm just going to double tap on the spline here and just plug it into offset max. So it's a nice, little more convenient single point here. And that's all we need in this one. I'm going ahead and close it up, and this one's good to go. Now we need to do the same thing for the second one, but in the second one, instead of this value, we want the negative of it. So what we do is drag out of here and just search for multiply. And just like before, we need to multiply by -1. So out of B, we drag out, search for create attribute. And in the double value, we go ahead and type in -1. So it goes ahead and multiplies by -1. And just like before, I'll plug it into offset min and reroute it to offset max as well and close it up. So very simple. And we want to do the same thing for these two, but for the new one, we're going to want to use Y instead. So what I'm actually going to do is take these 2 points, take all of this and duplicate it down here. And then I'm going to just open these up and plug in these values into offset min and max for both. Offset min, offset max. So effectively we have plugged into the same location as before, but this needs to be hooked up. And what we're going to do is take this divide and I'm going to plug it into the Y. So you can see it's the same math as the one here, except now it's for Y. And again, we just plug it in and offset these accordingly. So now we have all of these points, but there's too many. We need to prune some of them. So we need some difference nodes. So I'm going to right click and search for difference. And we're going to need to cut out all of the things. So I'm going to have 4 difference nodes. I'm going to duplicate this 3 times for each of the nodes. And basically, you're going to take the first one into the source and into the differences of the second. From the second transform points is going to go in the differences of the first and the source of the second, and the same way for the ones below. The first one goes into the source and then into the differences of the other one, and the second one goes into the differences and into the source. So they're kind of going right through each other, as you can see here. Each one of the transfer points goes into the source of one and differences of the other. Once you have all of these like so, we need to merge the points. So I'm going to drag out of the first one and search for merge points. It's going to get us a little conversion node here and get us our merge points node, which is great. So now you can take this out and just plug it in directly into this conversion node and plug them all in like so. And now we have our merge points. In fact, now if we sample this with the D key, we take a look at our square, you can see we actually are sampling only the points outside. So effectively, we are creating the walls here. Now, this is great. We're almost done with this part. The only thing left to do is kind of to offset them. Because if I was to drag out of here and search for a static mesh spawner, and then in the static mesh spawner, we can go ahead and add ourselves a mesh entry here by pressing plus, and in index 0 description, we can put in our static mesh. I'll go ahead and populate it with one of the meshes that I'm going to be using. And now if I take a look, you can see it is technically actually all there, but it's just not facing the correct way. And it also seems to be offset a little bit in X because the pivot is in the middle here and not in the edge. We need to offset that as well. So let's go ahead and adjust that real quick. So after this merge points, we need this a transform. After merge points, we're going to ourselves a transform points node, and then we'll plug that in right before the static mesh spawner and open up our transform points. Now for this transform points, we need to offset it by half of the length of the wall in X and offset it by our thickness in Y. So what we can do is drag out of our offset min and just search for make vector attribute, and we can plug both of this into the offset min and max. And just like before, in the make vector attribute, we'll go ahead and convert it to a vector regular. So we have access to X, Y, and Z. Now, for X, as I mentioned, we need to get the negative half. So we actually have already negative half over here, but this is already kind of being used in a vector before it's multiplied. So instead, we're just going to grab this divide by 2. And from here, I'm going to then multiply it by the same negative 1. So I'm going to take this and just duplicate it over. We're going to multiply by negative 1. And this is going to go into our X. And now for a Y, we need to get our actual wall thickness. So I'll take our wall thickness and just drag it all the way through. Now I'm keeping these here because I'm going to be collapsing this in a moment. It's going to make it easier to select. But as you see, for X, it is our wall size divided by 2 times negative 1. And our Y is just our wall thickness. By default, if you hover over this, you see anything that is not connected is 0, which is perfect in offsetting. Now, this takes care of the offset, but does not take care of the rotation. For the rotation, we actually do that in these transform points right here. So for the first transform points, in rotation min and max on the Z, we want to rotate it by negative 90 degrees. For the second point, we want to rotate it by 90 degrees, 180 degrees opposite of the first one. The third one is going to be at 0, and the fourth one is going to be at 180 degrees. Again, the exact opposite of the one before it. You can see we now have our walls all nicely together, and they're fit quite well. It makes a perfect little box here. Now, as I said, we're going to be reusing this quite a bit. So what we can do now is select all of this, everything basically between the original spline points, wall size, and wall thickness, as well as the static mesh spawner. We don't want that. We just want this last thing to be this transform points. Then we can right click and collapse into subgraph. Now the hotkey for this is Alt-J, so you can also use that. And now it's going to ask you where do you want to save it. So I'm going to save it into our PCG folder. I'm going to make a new folder called subgraphs. And here I'm just going to call it PCG create walls. And once I hit enter, you can see we now have a single graph here with the inputs already plugged in. And if I zoom out, here is our out, get actor property out, get actor property out 2. This is very ugly. Let's go ahead and fix this. Now we know our first one is original spline points, the second one's wall size, and third one's wall thickness. So if I double click on this PCG create walls, we get our graph back open and go ahead and clean it up if we'd like to. But the main thing is here in this input, we can go ahead and change the names of this so we know what's going on. So here in the top right under pins, let's go ahead and open it up, and we see 4 pins here. Now that's odd because we only see 3 here. Well, in fact, if you click this arrow, you get an extra in pin, and we don't want that. There's no reason for this pin. So for index 0, I'm just going to hit this caret and press delete. That gets rid of the first point. So that's step 1. Next thing we want to do is open up each one of these. And what we want to do is change the labels. So instead of out, we want to call it this original spline points or just spline points. Now the usage here can be normal, loop, or feedback. We are fine with normal. This is all correct. Allowed types point. It automatically sets that. It's great. And the pin status is what we want to change here. So pin status can be normal, required, or advanced. Normal is just a regular pin. Nothing special about it. Required means you have to plug something in for this to work. And that's what I want to do. I want to have this be required. If this was advanced, it would be hidden unless you opened it. Sort of like if you did this, how overrides and subgraph override comes up. That is what advanced does. So in our case, I want to change the pin status to required, and I want to do that in all three of these. Make them all required. Now for the second label, I'm going to call this wall size, and the last one is going to be our wall thickness. Again, all three are required. Now let's go to the output, and we have the same thing here. If I open it up, we have an extra out node. So just like before, on this out, I'm going to delete it. We only need this transform points out, and I'm going to change the label to be wall points. So now if I go to our PCG building graph, you can see we have now this nice subgraph that takes care of this all for us with some simple pins. So now we're all good with this. Now this is great. This is actually getting us our walls, and we can go ahead if we want to and change the size of this dynamically, and it'll go ahead and update, as you can see. So this is all working exactly how we want it, but it's only the first floor. We don't have a height control. So before we get into the actual interior and do the floors, let's finish up a way of copying these points up. And again, because we're going to need to also use this for the interior, we'll go ahead and create it as a subgraph, just as we did before. But in order to do that, we first need to have a way of actually figuring out how many points we need to generate up based on the amount of floors. So in order to do that, the first thing we need to do is figure out how many floors we need with a simple variable input. So I'll create a new variable. This is just going to be our floors. The type is going to be an integer. It is going to be exposed. I'm going to compile it and set the default floors to be 1. And I'm also going to make the slider and value range minimums to be 1. So that way you cannot accidentally make less than 1 floor for a building, which I think should make sense. You cannot have 0 floors on a building. So with that ready, we can go back to our PCG building. And I'm going to take our create walls here. I'm going to just move them down below for now. And right here below our spline data is where we're going to create our floor loops calculation. So what we're going to need is our wall size, just as we did before. And I'm also going to need a floors variable. So we created that already. So I'll duplicate it over and then change the property name to floors. So now we have both of these as inputs that we can just drag out here. So the way we're going to be doing this is by creating a spline using PCG itself. So we know where the actor is, where that blueprint is, and we should know the size of our actual floors, the height of them, and we should know how many floors we need to go up. And so we can go ahead and copy those points that many times and basically create a spline that samples it accordingly. So to get started, I'm going to right click and search for get actor data. This gets us the information from the actual actor, but by default, it says parse actor components. And really what we want is just get a single point. We want just a single point of wherever it is. In fact, if I go ahead and sample it with a D key, you can see it has now basically created a big selection that encompasses the entire floor, which is great. That means we now know that this is the size of our original floor and it's only 1 point. So now we need to take this point and copy it upwards, basically where the final floor will be. So we need to take the amount of floors we have, subtract 1 because we already have the very first floor, and then multiply it by the height of each floor, and then we can merge it together with the original and basically get both of those values. Let's go take our floors and we're going to subtract 1 from here. And again, as before, you can just drag out of B, or you can right click and search for create attribute, same thing. And we want to subtract 1 here and plug this into in B. And now we go ahead and take this and multiply it by our wall size. Now this assumes that the wall size and the actual wall height is the same. If you don't have the same wall size and wall height, you might need to have a separate variable for both. In my case, this should work just fine for the piece that I'm using, but just keep that in mind that at the current moment, because we're not dynamically grabbing that information, you might have different values for the height and width. But once this is gone ahead and multiplied it, we can go ahead and create a vector attribute just as we did before. Search for make vector attribute. And in this case, again, we make it a vector 3 and plug it into the Z because we want to move it upwards. And now we need to kind of merge it with this point. To do that, we can get a transform points. And then in this transform points, we want to offset it the min and max based on this vector. And this moves this point, but that's it. We want to still keep it. So to do that, I'm going to take our get actor data and drag out and search for a merge points. And now we want to merge it with this original transform points. And now if I go ahead and sample the merge points with D, you can see nothing has changed here, but that's because we're on floors 1. If I make floors 2, you can see we now have the points all the way up here. If I go floors 4, you can see it is copying the points higher and higher accordingly. And now we can use these 2 points to create a spline. So dragging out of merge points, search for create spline. And here in the detail panels on the mode, instead of create data only, we want to create the component itself. We don't want the actual spline. And now we need to get a spline sampler since we have a spline. Grab ourselves a spline sampler. And in this case, on the spline sampler, instead of doing on interior, we want to do on spline. But instead of subdivision, we want to change to the number of samples because this is effectively the amount of floors that we want. So let's go ahead and open this up. And here for num samples, we want to plug in our floors. So I'll take our floors and just drag it all the way through to num samples. And just like before, we want to make this unbounded. Now, if I go ahead and sample this point, you can see we do have a spline here, but it's so hard to tell what's going on. So I'm going to scroll down in the detail panel here. And over here under scale method extents, I'm going to change that to absolute. You can leave it at 1.0 scale. But now you can see that we're having full points. And here's the floors, 5 floors selected. And you have 1, 2, 3, 4, 5 points, all spread out according to the height of that we specified in here for the wall size. We're going to need to use this in a loop. And to use it in loops effectively, we cannot have the points all together. What I'm talking about is if I select this and press A, and then here in the bottom left, I can open it up and select PCG/PCG Building. You can see here, we have a single PCG point data node with all of the points here. Here's all the information from the points. That's fantastic. But it's a single point here in this dropdown. What we want is all of these to be a separate selection. So that way we can use them in a loop and loop on each one of these. So to do that is relatively simple. From this out, I'm going to search for attribute partition. Now by default, it's going to throw an error. And to fix that, open up the settings here. And under index 0 being last, you can hit this plus button and you want to change it for other properties index. And now if I press A on this, you can see each one is actually separated out, just like so. Now this is fantastic, but this is an output of a point. I want to output of an attribute because I don't care about the points themselves. I just want the information. So from this out, what I'm going to do is search for get attribute from point index. Now the input source, just like before, press plus and search for index. And now if I go ahead and select with it selected, press A again, you can see we have under PCG Building, here are all our points and we can get the attribute here. Now that is fantastic. Now I'm going to need to collapse this all to a subgraph to make it easier for myself. Now to make it extra easy, I'm going to need this as an output. So I'm going to drag out of here and just search for something like add. So that way I just have it plugged into something. So now what we can do is select everything here, including this crate, but do not select the floors or the wall size. And just like we did before, you can right click and do collapse into subgraph or press Alt J. And just like before, I'm going to save it into PCG subgraphs. And this is going to be our PCG get floor loops. Hit save. And now we have this graph here. And go ahead and delete this add node. We do not need it. We just need that attribute as the output. Now I'll go ahead and double click on here so that we can go ahead and just organize this just as the same way we did before. Delete the index 0 from the input. Change out to be floors. And change index 1 instead of get actor property out to be wall size. Now in my case, it's going to be a little bit easier if this is just in reverse order. So I'm going to just drag it between each other. So I'm going to have wall size first, then floors. And now in the output here, I'm going to delete index 0. And there we go. We're all good to go. So here's our wall size and our floors. And I've gone ahead and deleted it just because now I can have it a little more cleaner to reuse this node right above. So now we can go ahead and take this and grab ourselves a named reroute declaration node, press F2 and rename it to floor loops. So now we can reuse this to create the actual floors. So let's go ahead and do that with our create walls setup. If you're enjoying the tutorial so far, I would love to hit the like button and get subscribed if you're new for more awesome tutorials like this. Let's get back to it. So now we're going to need to use these points and actually create a loop for this. This is going to be our first loop that we are making. And to show you that you can create this from default, in our PCG folder, I'm going to make a new folder called loops. And I'm going to right click, search for PCG, do a regular PCG graph as well as always. And this is going to be our PCG copy points up _ advanced. because this is going to have a little more options than the default one that we're going to be using for the actual room interiors. That one's going to be a little more simple. So what you can do once you create one of these is just have it selected and just drag it into your PCG graph and let go. And then you have the option of create a subgraph node or a loop node. And we want a loop node. So again, just select loop and you can see there's no inputs or anything, but that is fine. We can come here and just double click it and open it up to get our actual regular input output PCG graph as you would normally. Now we're going to need some inputs and outputs. So let's go ahead and open our input and output and let's change these up. For input, the first thing we're going to need to do is change the allowed types to be points. And we want these instead of advanced to be required because we want to make sure we always get any points in. Otherwise, they cannot possibly work. And then we're going to need a few things. Starting with an index that is going to be allowed types attribute set, which is our attributes as you see here by this node. And this is going to be the first one that has a different usage. This is going to be a loop. So we're going to be looping in all of these points. And so we're going to change the pin name from new pin to loops. And because this is the advanced version, what we're going to allow to do is to input a separate static mesh when we want like a different floor design. So every second floor, every third floor, let's say, we want a different design. And then maybe we want to offset those floors up or down where the design starts. So in order to do that, this is the more advanced version. So we're going to have the inputs for that. So let's add 2 more inputs. Now both input 3 and 4 are going to be normal, are going to be allowed types attribute set. Now input 3 is going to be our unique floor every X, because we need to know every how many floors we want a unique floor at. And for our 4th pin, it's going to be our unique floor offset. Fantastic. And now for our output, we want to output 2 different types of points. So for allowed types, we change it to point, and we add 1 more and also of type point. Now we're going to have mesh 1 as being the name of the first output, and mesh 2 will be the second output. Because depending on which one goes into which will depend on which one we actually go ahead and render out. And the final thing we kind of want to grab here is actually one other thing, which is also going to be a attribute set. And this is going to be our wall height. Now in our case, we're using the same wall size for both, but I'm going to go ahead and configure it as a wall height so you can see how it's all configured. Now in this previous setup for the get floor loops, we did use the wall size instead of the wall height. And you'll see what happens when we do this. It'll be fine. We will adjust it accordingly, but you will see how this wall height can be a little bit different. So what we need to do is from here, grab ourselves some transform points, and we want to open it up to get access to offset min and offset max, as we have done plenty of times before. Drag out of here, make vector attribute, and we change it to a vector 3 and plug it into both the offset min and max. So now we need to grab our Z. And for that, we need to grab our wall height, and then we want to multiply it by the loops index. So to do that, actually just right click and search for get loop index. And we just go ahead and multiply the two and then plug that into the Z. So now it's going to go ahead and offset it based on the amount of times it's going through it. So this is wonderful, but we do have these unique floor every X and the offset. And we want to make use of that to create different meshes. So just like before, we're going to get our loop index because we need to know which floor we're actually doing this on. And then we're going to add our unique floor offset because basically we're modifying the index where the floor is happening by our offset. After that, we want to grab ourselves a modulo. This node will allow us to basically figure out when is it that we have something that is every third, because it will divide nicely into that number. So let's say 3, 6, 9 all divide nicely into 3. And every other number has decimal points. So for this one, we want to plug in unique floor every X into B, and then we want to compare it to see which one it was. So from here, I can go ahead and search for greater to do a compare operator. You can see if it is greater than 0. So from B, I'll search for create attribute as we've done before. And we want to just check that it is greater than 0. Because again, if it divides nicely into that value, it's always going to be 0, or it's going to be greater than 0 because it has some fraction. Now from here, from this transform points, I'm going to search for ourselves for a branch. And if you open it up, we have this output to B. So we want to take this out and plug this to output to B. And I can close this back up. And now we can take this output A, plug into mesh 1, and output B into mesh 2, just like so. So in the end, you're kind of left with a graph like this. To make it a little cleaner, I'm going to take this unique floor offset. I'm going to move it above the other one here, just so these two loops are kind of a little cleaner. And if I go back to our PCG building, you can see here is our node with everything enabled. So to plug everything in, I'm going to detach the static mesh spawner. I'm going to take our wall points and plug them into our in. For our loops, I need to get our floor loops that we have created before, plug those right in, which are these right here that we created. Now this unique floor, we don't have as variables as of yet. So let's go ahead and create these. In our BP building, I'll go ahead and create 2 new variables. The first one is going to be our unique floor every X. And the second one will be unique floor offset. Both of these will be integers and they will be exposed. I'll go ahead and compile this, and I'll go ahead and change the unique floor every X to be 2. And I'll set the slider and value range here to be 1 for minimum. So that way we don't get a 0 and this doesn't error out. And then unique floor offset, I'll set it to be 0 by default, and I'll make it 0 for the slider and value range minimums. So you cannot go negatives. Now the last one we're going to want is our wall height. So I'm going to create a new variable called wall height. And this one is going to be a float. It's going to be exposed. I'll actually move it right below wall size for convenience. I'll compile this, and this will be a value of 300. So now we can go ahead and plug all the points right in here. So I'm going to take these actor properties, I'm going to duplicate them, and I'm going to duplicate it one more time so we get 3 of them. Now for this unique floor offset and every X, I'm just going to go to our BP graph. I'm going to go to our blueprint. I'm going to select it, and I'm just going to copy it. And then I'm just going to paste it in so that way I know for sure that I'm pasting it in exactly the same way, because it is a long variable name, and then I can just plug it in without any issues. Take our unique floor offset, copy it. I'm here, paste it in, plug it in, and same thing with wall height. There we go. We have everything plugged in. So now what I can do is take our mesh 1, plug it into our static mesh spawner, and I'm going to duplicate the static mesh spawner, plug it in for mesh 2, and then the second one under mesh entries, I'm going to change the mesh that I'm spawning. So here we go. Here's a different mesh. And now if we take a look, we have our walls all going up 5 floors up, and we have a different design here on every second. And if you want to offset them, we can change the unique floor offset to be 1, and you can see it is a different offset. We can change the unique floor every third. And now you can see here, it is actually, this is the unique one. In this case, I'm going to take our 2 static mesh spawners and I'm going to swap their positions. And now this is the actual unique one, which is what I wanted. And of course, I can go ahead and offset this, and you can see every third one is now different. We can change the amount of floors of these, and it will go ahead and populate upwards accordingly. Now again, because we have now added this wall height, up here where we have wall size for get the floor loops, I'm actually going to duplicate it here for this wall height. I'm going to plug this into our wall size and detach the original. And then I'm going to come into this get floor loops graph. Instead of wall size, I'm going to rename this to wall height. So that way we're just consistent between them. But as you saw in our case, it was fine. But to make sure that we have no issues down the line, we can go ahead and have these be actually proper wall height. So I'll go ahead and just rename this to get floor loops and comment it up. I'll make a comment for the original one, which is just to get spline points. And now this whole section is done. And this is to generate exterior walls. So now that all of this is done, let's go ahead and generate the actual floors on the inside, because it's currently pretty empty. So the floors ones is actually going to be relatively simple. For that, we're going to need our wall size. So I'll just come up here, grab our wall size get actor property, and just duplicate it down for convenience. We're going to get half of that size. We're going to divide it by 2 using the divide node and the create attribute with a value of 2. Now the floors are going to be relatively simple. So let's go ahead and just take our points and copy them up, because we already have them. But for that, we're going to need a new loop. And this one's going to be a simple version of the one we just made that just is going to copy points upwards. So in our loops folder, I'm going to right click and search for PCG and grab ourselves a PCG graph. And this is going to be our PCG copy points up underscore simple. Just like before, I'm going to take it and just drag it right into our PCG Buildings graph and select the loop node. And we can go ahead and open it up so we're ready to work with it. Let's open our input and output. For our input, the type is going to be point by default. Instead of advanced, we're going to say required. And then we're going to need one more set of inputs. And this is going to be our attribute set. And this is going to be our loop, because this is actually the amount of floors that we need. So I'll just type in this loops. And that should be good to go. And the output here, instead of allow types any, we go ahead and select points, and the label will be mesh. And the last thing we're going to add here is our wall height as our input, as we did before. Wall height, type, attribute set. So now we can go into our advanced points and grab this section here that we did for the advanced version. I'm going to copy this and paste it right in. So we're just taking basically just the part we need from here, and this wall height goes ahead into this multiply, and this output goes into the mesh. And it is as simple as that. Now if we go to our PCG building, we can plug everything in. So from the in, I'm going to drag out and search for our original spline points. Now when you do that, for some reason it gets disconnected, in which case just plug it back in. It is completely fine. I'm going to search for our floor loops, plug those into our loops, and I'm going to take our active property of wall height and plug that into wall height. Now, if I plug in a static mesh spawner here and add ourselves an entry, and I'm going to go ahead and plug in something we're going to use for now for the floor, like so. And if I take a look at it, you can see it is just a little bit too small, and it is kind of offset because of how the pivot is on it. But that's okay. We can go ahead and move the pivot on it. And if we want to, we can even change the material on it. So if you want to change the material, you can go over here under override materials, right below the static mesh, add an entry. And for example, I can plug in this wood floor texture. And now we can take a look, and now we have this wooden floor texture applied on top of this actual roof mesh, but that is fine. And if we want to, we can go ahead and just adjust the tiling here, for example, to 4x4 and make it a little more tiled, which might look a little bit better. This is just a mega scans texture that we're using, so this should work just fine. But now let's go ahead and offset this and fill in this gap. So to do that, we're just gonna need a transform points right before the static mesh spawner, just like so. Let's open it up to get access to all the offsets. We're going to offset the scale, and we're going to offset the position. Let's start with the position. For that, we're going to get the wall size. So I'll grab our wall size from over here and just duplicate it down for convenience. We're going to offset it by half in both X and Y. So I'm going to take our wall size and divide by half by using, again, a create attribute. And then we're going to create a vector from this. So make vector attribute of type vector3, and this is going to go into our offset min and max. So you can plug that in right away. Now, instead of this going into the X, we're actually going to want to have this go into the Y, and that is going to be our half of our wall size in Y. And we also want to do the negative of it into X. So I'm going to take this out and then multiply it by -1 by plugging in -1 create attributes into B and plugging that into X. So you're left with something like this. And now we need to modify the scale. Now the scale is going to be based off of the wall size, and we need to get a property for the floor size. Now we don't have a value here, but for now we're just going to hard code it. I'm going to go ahead and divide this, and I'm going to do a create attribute. And in my case, the actual floor is 300 units. So I'm going to divide this by 300, and then I can plug this into the scale min and scale max and close this all up. And now if we take a look, we have our floor perfectly inside. As you can see, it is going right up to the edges here, and it is now on every single floor like so. Down the line, we're going to be actually making it so we can swap these dynamically into different meshes, and they will all scale accordingly. But for this very first part, it's just easier to go ahead and hard code some things for the future. But of course, if you're using this for your own meshes, you might need to adjust some values here and there, depending on your pivots, etc. Now, as always, the project files for this are available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot, and it helps me out greatly. And if you have any questions or just like to join the community, the link to the Discord is down below. Stop by and say hi and join this wonderful community. And now, thank you again to the Patreons. Let's get back to it. So with this all set up, I can now go ahead and just adjust the unique floors. I could change the amount of floors dynamically, and everything gets actually updated, including the floors. They all get populated here. If you go into Unlit, it's easier to see. And just like that, we have a nice dynamic floor that can be updated anytime and change the size and the shape to be whatever you'd like very quickly. And the nice thing about this one, unlike the previous one, is you could actually tilt it. The previous design was not able to tilt, or if you wanted to put this in a place where it'll be like the Leaning Tower of Pisa, you absolutely can now, which the previous version was not able to do. Hopefully this taught you a lot about the different kind of loops and everything. I have gone ahead and kind of went over some of the stuff a little faster, because I do have tutorials that go a little more in depth on things like loops. And if you want to actually learn more about loops and PCG, you can check out this video right here, where I teach you how to use loops and the things that go into it in a little more depth.